Hello! In this video we're going to be graphing absolute value functions. So let's first of all take a look at our parent function and let me share with you where it comes from. So what you see on my screen right now is a graph of y equals x. Now with y equals x, you'll notice that the slope is 1 over 1 and that your y-intercept is actually 0. So you would graph this by putting a dot at 0 and go up 1 over 1, up 1 over 1, up 1 over 1, and so on. Well, when you take the absolute value of that, absolute value is a number's distance from 0. What ends up happening is when you take the absolute value of a number, since number is distance, you're going to come out with a positive value. So that means all of those negative values that we have right here, we grab this, these are actually going to become positive. So take all my negative y values and make them positive. And what that actually does is it flips it over the x-axis, and this becomes our parent function. So you'll notice all of our output values are all positive. Okay, what we're going to do today is we're actually going to graph a variety, and there's only 4 examples, actually 3 or 4 examples, I don't remember, and I'm going to show you how to graph these. We're going to have to do an input-output table, but it's going to be a short input-output table. Okay, so very much like quadratics, we have to find the turning point for this. So in other words, we have to find the base of that v. To do that, it's actually very easy. All you do is you focus in on the absolute value part. So ignore everything else. We're just going to focus in on the absolute value. And you're going to ask yourself this one question. What makes that 0? What value of x would make that expression 0? And hopefully you're coming out with 1. Okay, and now all you do is you pick a couple values smaller, so say 0 and -1, and a couple numbers bigger, 2 and 3. And what we're going to do is we're going to plug those into our equation here. So let's do that. Let's plug in -1. So the absolute value of -1 minus 1, minus 2, so that's the absolute value of -2, minus 2, so that's 2 minus 2, output is 0. Let's plug in 0. Absolute value of 0 minus 1, minus 2, so absolute value -1 minus 2, so 1 minus 2, that's going to be -1. Let's plug in 1. Absolute value of 1 minus 1, minus 2, so 0 minus 2, that's going to give me -2. And what you're going to find is just like quadratics, this should be symmetric. So if I plug in 2, absolute value of 2 minus 1, minus 2, so that's 1 minus 2, that gives me an output of -1. Let's put in 3. 3 minus 1, absolute value, minus 2, so that's going to give me 2 minus 2, 0. Okay, now let's just graph it. So -1, 0, 0, -1, 1, -2, 2, -1, 3, 0. There's your v. I'm going to freehand this, which is not going to be pretty here. And there you go. Now if you're using a piece of graph paper to do all of these, so in other words if you're doing one grid to graph all of these, that's perfectly fine. Just make sure you label. So let's take a look at another example. All we're going to do is we're going to take a look at just the absolute value part. That's it. Just the absolute value part. And we're going to ask ourselves, okay, what makes that 0? So hopefully you're looking at that and saying, okay, well -2 makes that 0. Great. Now all you do is you pick a couple numbers smaller and a couple numbers bigger. So a couple numbers smaller would be -3, -4. A couple numbers bigger would be -1 and 0. So let's just put those in and see what we get. So absolute value of -4 plus 2, then minus 3, so that's the absolute value of -2 minus 3, so 2 minus 3, that's -1. Let's plug in -3, the absolute value of -3 plus 2, minus 3, so this is the absolute value of -1 minus 3, so 1 minus 3, that should be -2, Let's plug in negative 2, so the absolute value of negative 2 plus 2 minus 3, so that's 0 minus 3, that's going to be negative 3. I will color code that. That's known as our vertex. That's where it's going to change. And you know that term vertex. We've been talking about that. That's something that we have in quadratics. Okay, and let's see. Since this is symmetric, the absolute value of negative 1 plus 2 minus 3, so 1 minus 3, that's going to be negative 2. So you'll see the symmetry here, and that means that's going to be negative 1. So all we have to do is just graph those values. So negative 4, negative 1, negative 3, negative 2, negative 2, negative 3, negative 1, negative 2, and 0, negative 1. Here's our v. Now, hopefully you also remember that this, from transformations, that this is going to move it down 3, and this is actually going to move it left 2. So you'll notice our parent function has been shifted left 2, down 3. Okay, let's take a look at this one. Now, if we were working on transformations, you would notice that this would be up 4. That's a very bad up, but that's okay. Up 4. This actually would go counterintuitive. So this goes right 4. But then this right here, this is going to reflect it. Now that negative is not inside with the x, it's on the outside. So what we're doing is we're changing our y values, which means it reflects over x axis. So this thing isn't going to be opening up, this is actually going to be opening down. Okay, just like all the other ones, we need to find the middle. So to find the middle, we're going to focus on one part and one part only. We're going to focus right here. Okay, and we're going to ask ourselves what makes that 0. And hopefully you're saying 4. Okay, let's fill in the chart here. And again, you could use your graphing calculator to do this. If you are using the graphing calculator, there is that really fancy button next to the 9 on your TI Nspire. There's a button next to your 9. It's a menu. If you click on that, you're going to see the absolute value. So you'll see the symbol for absolute value in there. So you want to hit the button next to the 9. Okay, so I'm going to plug in, let's see, let's get a few numbers smaller. So let's do 3 and 2, a couple numbers bigger. It's going to be 5 and 6. So let's put in 2. So it's 2 minus 4 plus 4. So that's negating what you get from the absolute value of 2 minus 4. So that's negative 2 plus 4, which is 2. Here's our next one. So let's see. That's going to give me an output of 3. My next one is actually my vertex. It's very important. So that's going to be 4. And if we did this correctly, you should see the symmetry here. Yep, see the symmetry. So I'm just going to take our word for it and say that this is going to come out to be 2. And I'm just going to sketch it. Now you know this should be opening down. Whoops, put that in the wrong spot. There we go. Oof, just had enough room. And there you go. That's what it looks like. I don't think I have a fourth one here. I do not. So what I'm going to have you do, there's only 6 problems for you to practice on. You could use one piece of graph paper with one grid. Just make sure that you do a couple things for me. Make sure that you do a quick input-output table. I don't care if you take your values right from your graphing calculator. That's perfectly fine. But you do need to find the middle. I would like to see the middle of the graph as the middle of your input-output table. Just like with quadratics, you have to find the middle. And you do a few numbers smaller and a few numbers larger. I want to see that. So you can use one grid to do all your graphs, but just make sure that you have a separate input-output table for each one. Whether or not you show all the work like I did on this page right here, I don't care. All I care about is I need an input-output table and the graph. Okay? And if you do more than one, make sure you label. All right, good luck.